Hey everyone, I want to talk to you about uniform random variables, the discrete uniform random variable, which we will actually learn in the continuous version a little bit later. These are so simple that they barely warrant their own video. But yeah, it also felt a little bit stupid to not give you the easiest example. So let's talk about uniform random variables. A uniform random variable, in a uniform random variable, all outcomes are equally likely. So for instance, if you're doing the pick a number between 1 and 10 game, that's the classic example of this, right? The notation looks something like this. Instead of saying the uniform random variable from 1 to 10, you would say like U1, 10, right? That's pick a number between 1 and 10 essentially. Yeah, so all the outcomes are equally likely. Let's see an example. This should be quick. So we have a computer pick a random integer between 1 and 10. So no picking like pi, which by the way, if you ever pick them, just here's a tip for you. If you're actually watching this video, if I say like, oh, 2 people want to do something, pick a number between 1 and 10, closest person gets to do it. I always pick pi because I say pick an integer. I said pick a number between 1 and 10. However, I'm gonna have my computer pick a number or pick an integer between 1 and 10, no real numbers allowed here. So I'm gonna call that number x, and I wanna find the following things. I wanna find the probability that x is 6. Well, if it was random, there's an equal probability of picking every number between 1 and 10, of which there are 10, meaning that there is a 1/10 probability of getting any particular number. So let me, it feels a little silly to do this, but let's go ahead and write down the outcomes, right? So we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, each one of them with probability 0.1 or 1/10. So the probability of getting just 6 would be 1 out of 10 or 0.1. Equals 0.1. Bam, that was easy. All right, let's fancy it up a little bit. Let's find the probability of getting x less than or equal to 6. So if I look at that, that's these guys, of which there are 6, each of which has probability 0.1. So that would be 0.6 is the total probability of getting that one. So this is 0.6, 0.6. Let's find the probability of getting x greater than 6. Well, if you're clever, you could note that that is simply 1 minus the probability of getting x less than or equal to 6, right? Greater than 6 is all the numbers bigger than 6. So 7, 8, 9, or 10 are the possibilities, of which there are 4. So we have 0.4. Whoops, that was one too many mouse presses there. 0.4. And the probability of getting x greater than or equal to 8, well, that would include 8, 9, and 10. So there are 3 of those. So the probability of that is 0.3. That's all there is to it. Uniform random variables are incredibly simple. They will get very slightly more complicated, not a lot, but a little bit more complicated when we go on to continuous random variables in topic 6, and there's a uniform continuous uniform variable there too. Yeah, that's all I want to say about these. Oh, by the way, there is not even a calculator function for these. They are that simple. The makers of the TI 81, 84 rather, realized that there's simply no need for uniform CDF or uniform PDF. Why bother? So they don't. There isn't one in there. You just do it in your head all the time. It's always, remember that it's 1 over however many outcomes there are. That's what the probability of all of them is. Yeah, that's all I want to say. So I'm going to go ahead and stop the video right there. I will see you guys in the next video.